The solar-powered spacecraft which left Earth 5 years ago has made history by entering into Jupiter's orbit. NASA's Juno probe fired its main rocket engine at 4.18 MBST, slowing itself down from a speed of 165,000 mph enough to drop into a sweeping orbit around the planet. With Juno on autopilot, the delicately choreographed move came without any help from ground controllers, so the spacecraft's mission control erupted with cheering and applause when the orbit was confirmed at 4:53 a.m. BST. The mission's chief scientist, Scott Bolton, congratulated the team, saying, "You've just done the hardest thing NASA's ever done," as the technicians and scientists celebrated completing the complex approach procedure. At a briefing this morning, Bolton, the mission's principal investigator, said, "We're there. We're in orbit. We conquered Jupiter." He added, "What Juno's about is looking beneath that surface. We've got to go down and look at what's inside, see how it's built, how deep these features go, learn about its real secrets." Juno will peer through the swirling clouds in the planet's upper atmosphere and map the interior from a unique vantage point above the poles. During its mission of exploration, the probe will circle the Jovian world 37 times, soaring low over the planet's cloud tops. Scientists will for the first time be able to see what lies beneath Jupiter's atmosphere, and help unlock secrets about how the solar system formed. Among the lingering questions are how much water exists? Is there a solid core? And why are Jupiter's southern and northern lights the brightest in the solar system? There is also the mystery of its great red spot. Recent observations by the Hubble Space Telescope reveal the centuries-old monster storm in Jupiter's atmosphere is shrinking. The spacecraft will end its mission in 2018 when it takes a swan dive into Jupiter's atmosphere and disintegrates, a necessary sacrifice to prevent any chance of accidentally crashing into the planet's potentially habitable moons. Speaking to ahead of this morning's breaking maneuver, Dr. Jared Espley, program scientist for Juno at NASA, said, "It's a very unusual time in the life of a scientist or engineer when these big events happen, because you genuinely feel a connection to a big event, a bigger part. It's something that as a space agency we're super excited to do, but as a government we're happy to have this opportunity to do the science. You feel that you're representing your country but that you're also representing humanity. This is the spacecraft that we have sent to another planet, and it's just remarkable that we as a species have the capability and the desire to understand what's going on with other planets outside of our own. Juno is currently traveling through a hostile radiation environment, but it should be able to withstand it," said Kenny Starnes, program manager for Lockheed Martin, which built the spacecraft. The probe's camera and other instruments were switched off for the arrival, so there won't be any pictures at the moment the spacecraft reaches its destination. Scientists have promised close-up views of Jupiter when Juno skims the cloud tops during the 20-month, $1.1 billion mission, with a public vote on areas to focus on. The fifth planet from the Sun and the heftiest in the solar system, Jupiter is known as a gas giant, a ball of mainly hydrogen and helium, unlike rocky Earth and Mars. But scientists still don't know exactly what lies at its center, or whether it formed within its current orbit, or migrated from elsewhere in the solar system. With its billowy clouds and colorful stripes, Jupiter is an extreme world that likely formed first, shortly after the Sun. Unlocking its history may hold clues to understanding how Earth and the rest of the solar system developed. Named after the Roman god Jupiter's cloud-piercing wife, Juno is only the second mission designed to spend time at Jupiter. Galileo, which launched in 1989, circled Jupiter for 14 years, beaming back splendid views of the planet and its numerous moons. It uncovered signs of an ocean beneath the icy surface of Europa, considered a top target in the search for life outside Earth. The trek to Jupiter, spanning nearly 5 years and 1.8 billion miles, took Juno on a tour of the inner solar system, followed by a swing past Earth that catapulted it beyond the asteroid belt between Mars and Jupiter. Along the way, Juno became the first spacecraft to cruise this far out, powered by the Sun, beating Europe's comet-chasing Rosetta spacecraft. A trio of massive solar wings sticks out from Juno like blades from a windmill, generating 500 watts of power to run its 9 instruments. Plans called for Juno to swoop within 3,100 miles of Jupiter's clouds, closer than previous missions, to map the planet's gravity and magnetic fields. Juno is an armored spacecraft. Its computer and electronics are locked in a titanium vault to shield them from harmful radiation. Even so, Juno is expected to get blasted with radiation equal to more than 100 million dental X-rays during the mission. Last week, stunning new images and the highest resolution maps of Jupiter at thermal infrared wavelengths showed a glowing view of Juno's target, a week ahead of the NASA mission's arrival at the giant planet. The maps reveal the present-day temperatures, composition and cloud coverage within Jupiter's dynamic atmosphere, and show how giant storms, vortices and wave patterns shape the appearance of the giant planet. The high-resolution maps and images were created from observations with the European Southern Observatory's Very Large Telescope in Chile, using a newly upgraded thermal imager called VISIR. The observations were taken between February and June 2016 to characterize Jupiter's atmosphere ahead of Juno's arrival. We used a technique called lucky imaging, whereby individual sharp frames are extracted from short movies of Jupiter to freeze the turbulent motions of our own atmosphere, to create a stunning new image of Jupiter's cloud layers, said Dr. Lee Fletcher of the University of Leicester. At this wavelength, Jupiter's clouds appear in silhouette against the deep internal glows of the planet. Images of this quality will provide the global context for Juno's close-up views of the planet at the same wavelength. Dr. Fletcher and his team have also used the TEXCS spectrograph on NASA's Infrared Telescope facility in Hawaii regularly to map Jupiter's changing appearance. The team made observations at many different wavelengths, optimized for different features and cloud layers in Jupiter's atmosphere, to create the first global spectral maps of Jupiter taken from Earth. These maps will help set the scene for what Juno will witness in the coming months. We have seen new weather phenomena that have been active on Jupiter throughout 2016. These include a widening of one of the brown belts just north of the equator, which has spawned wave patterns throughout the northern hemisphere, both in the cloud layers and high above in the planet's stratosphere, said Dr. Fletcher from the University of Leicester's Department of Physics and Astronomy. Observations at different wavelengths across the infrared spectrum allow us to piece together a three-dimensional picture of how energy and material are transported upwards through the atmosphere. Both sets of observations were made as part of a campaign using several telescopes in Hawaii and Chile, as well as contributions from amateur astronomers around the world, to understand Jupiter's climate ahead of Juno's arrival. The ground-based campaign in support of Juno is led by Dr. Glenn Orton of NASA's Jet Propulsion Laboratory. Once in orbit around Jupiter, Juno will skim to within just 3,100 miles above Jupiter's clouds once a fortnight, too close to provide global coverage in a single image. The Earth-based observations supplement the suite of advanced instrumentation on the Juno spacecraft, filling in the gaps in Juno's spectral coverage and providing the wider global and temporal context to Juno's close-in observations. The combined efforts of an international team of amateur and professional astronomers have provided us with an incredibly rich dataset over the past 8 months, said Dr. Orton. Together with the new results from Juno, this dataset will allow researchers to characterize Jupiter's global thermal structure, cloud cover and distribution of gaseous species. We can then hope to answer questions like what drives Jupiter's atmospheric changes, and how the weather we see is connected to processes hidden deep within the planet. No previous spacecraft has orbited so close to Jupiter, although 2 others have been sent plunging to their destruction through its atmosphere. To complete its risky mission, Juno will have to survive a circuit-frying radiation storm generated by Jupiter's powerful magnetic field. The maelstrom of high-energy particles traveling at nearly the speed of light is one of the harshest radiation environments in the solar system. To cope with the conditions, Juno is protected with special radiation-hardened wiring and sensor shielding, and its all-important brain, the spacecraft's flight computer, is housed in an armored vault made of titanium and weighing almost 400 pounds. Dr. Scott Bolton, Juno's principal investigator from Southwest Research Institute in San Antonio, U.S., said, "We are not looking for trouble, we are looking for data. Problem is, at Jupiter, looking for the kind of data Juno is looking for, you have to go in the kind of neighborhoods where you could find trouble pretty quick." Juno will study Jupiter's composition, gravitational and magnetic field, and search for clues about the planet's formation and the source of its raging winds, which can reach speeds of 384 mph. It will also deliver stunning color photos via its Juno camera, which is a wide field of view geared for panoramic images. To provide electrical power, the spacecraft carries 3 huge solar panels, each 29 feet long and almost 9 feet wide. The previous record for a close approach to Jupiter was set by the American Space Agency NASA's Pioneer 11 spacecraft, which passed by the planet at a distance of 27,000 miles in 1974. Only one previous spacecraft, Galileo, which visited Jupiter and its moons from 1995 to 2003, has orbited the planet. Galileo made wide orbits at distances of hundreds of thousands of kilometers that kept it out of serious danger from the radiation, although it suffered a number of technical anomalies. The spacecraft sent a small probe on a one-way trip through the clouds of Jupiter, and was eventually itself crashed onto the planet at the end of its mission. As a further safeguard, Juno is programmed to follow a long orbital path that avoids Jupiter's radiation belts as much as possible. Despite these measures, the probe is not expected to last much longer than its planned lifespan of 20 months. At the end of the mission, NASA plans to send the probe headlong into the Jovian atmosphere to collect as much data as possible. Chief Radiation Monitoring Investigator Heidi Becker, from NASA's Jet Propulsion Laboratory, said, "Over the course of the mission, the highest energy electrons will penetrate the vault, creating a spray of secondary photons and particles. The constant bombardment will break the atomic bonds in Juno's electronics." A plaque dedicated to Galileo and provided by the Italian Space Agency is also on board. Measuring 2.8 inches across, it shows a portrait of Galileo and a text penned by the astronomer in January 1610 while observing Jupiter's 4 largest moons, later to be known as the Galilean moons. Juno was launched into space by an Atlas V rocket from Cape Canaveral, Florida, on August 5, 2011. The mission is part of NASA's New Frontiers program of robotic space missions, which last year saw the New Horizons spacecraft obtain close-up views of dwarf planet Pluto.